Hello everyone, my name is Chivizo NTR. Today I'm going to teach you on mechanical drawing and design N6. Our topic of today, it will be bending and twisting of shafts. Then on the bending and twisting of shafts, then I'm going to concentrate on the bending, shear force, bending moments and twisting of shafts. Here with me, if you can check, I'm giving an examination question with me here. Okay, let's start. A simply supported shaft is carried by bearings at A and B, which are 4 meters apart. A pulley mounted on the shaft exerts a downward load of 12 kilonewton at a point 1.5 meters from bearing A. The shaft transmits 50 kilowatts at 200 R per min. The allowable shear stress is 40 MPa. Required. You are required to calculate the following. Number one, you are required to calculate the reaction at A and B. From there is where you are going to earn 4 marks. You are required to draw the shear force diagram and determine the maximum shear force. Here is where you are going to earn 4 marks. Number 3, draw the bending moment diagram and determine the maximum bending moment. In this one, you are going to earn 4 marks. Calculate the torque transmitted by the shaft. Here, you are going to earn 4 marks. Calculate the equivalent twisting moment. Here, you are going to earn 4 marks. Calculate the required shaft diameter, which is 10. Total, it will be 30. So let's go to the memorandum. Then let's start by calculating number one. If you can check, we are going to calculate reactions at A and B. Okay, you can calculate reactions by applying the law of moment. Sometimes you can say anti-clockwise moments equals to clockwise moments. Or here, if you can check, we took our moments about A. Okay, RB multiplied by 4 equals to 12 multiplied by 1,5. RB equals to 18 divided by 4. RB equals to 4,5 kilonewton. There is something which you have to understand here. Before you can calculate this, it is also good to sketch. If you can check, it is good for you to sketch. It's where you are going to take your moments. Then after that, here you are going to substitute. RA equals to 12 minus 4.5. RA is 7.5 kilo Newton. So answers RA equals to 7.5 kilonewton. Then RB equals to 4.5 kilonewton. So step number 2, it's where you are going to calculate the shear force diagram. From A to load, shear force equals to positive 7.5 kilonewton at load position. Shear force equals 7.5 minus 12. Shear force equals minus 4.5 kilonewton. So from load B, shear force equals to minus 4.5 kilonewton. At B, it will be minus 4.5 plus 4.5, which is 0. Maximum shear force here, if you can check, is positive 7.5 kilonewton. This is the maximum shear force. Then after here, it's where you are going to earn 4 marks. Let's go to the bending moment. The bending moment is all about the force multiplied by distance. Maximum bending moment occurs under the load, where M equals to RA multiplied by 1,5. This is about reaction. Reaction A multiplied by the distance. Our distance is 1,5. Then M equals to 7.5 multiplied by 1,5. M equals to 11,25 kilonewton and meter. Answer, it will be maximum bending moment. If you can check, the maximum bending moment is this one here, which is 11.25 kilonewton meter. Then let's go to step number 4. In step number 4, what you have to understand, always when you are doing design, you must understand, you must always remember these tips. or this tip. First, get the formula. Step number 2, substitute from the formula. If you have subject to the formula, it's better to do the subject of the formula on the second step. Then you go to step number 3. It's where you're going to use substitution, or then from, but here we use substitution on the second step. Why? Just because we didn't do any subject of the formula, where our T was 2.39 kilonewton per meter. Then answer, it is 2.39 kilonewton meter. Let's go to number 5, equivalent twisting. For equivalent twisting, okay, we have our formula. We all know that our formula, it will be TE equals the square root of moment squared multiplied by T squared. We have already calculated our T. Our T is 2.39, but this is 11.25. If you can check, this is the moment. 11.25 is the maximum bending moment. If you can check, we calculated it. This is maximum bending moment. Remember, this one is not given at this time. Then we calculated it. Okay, it is always good to use your calculator. Just use your calculator and try to check if these figures are correct. Then it will also help you to develop design muscles or tricks and skills in design. Okay, our answer, it will be TE. TE, remember, TE is our equivalent torque, which is equals to 11.50 kilonewton meter. Then number 6, we are going to design the shaft diameter. Okay, we are converting 11.50 kilonewton per meter, then to 11,50 multiplied by 10 power 6 per millimeters. Okay, why we are why now are we converting? Is because if you can check on your question, um this one is in meters, this one is in meters. Calculate the required shaft diameter. Practically, shaft diameter must be in millimeters. The snare diameter, shaft diameter, it must be in millimeters. Okay, so let's go and check. Now the formula we are going to use, TE equals to 16 divided by pi divided by 16. Then here, if you can check, we are going to do d power 3 subject of the formula, where we are going to substitute. Remember what I said, you do d subject of the formula before you substitute. That is a professional design practice or standard of design. Then d power 3 equals to this one, you substitute. Then after that, our d equals to 11.3. It will be 113.6 millimeters. Choose standard size. This one, our standard size is 11, it's 115 millimeters. Answer, our d equals to 11, it will be equals to 115 millimeters. Then here you are going to earn marks. Okay, here with me I've got some exam tips for learners, or so that you can understand what's going on. Tip number 1, find reaction first. If you find a question like this, where they are requesting you to calculate reaction bending moment, the shear force, what you have to understand, calculate reactions first. Calculate reaction first. Never draw the shear force diagram before calculating the support reaction. Always start with the sum of moment equals to 0 and the sum of vertical moment equals to 0. So tips again, shear force diagram rule: moving from left to right, upwards force, shear goes up, down force, shear goes down. Tip number 3, let's go to tip number 3, where you are going to do bending moment. For a single point load, maximum bending moment occurs directly under the load. Tip number 4, in shaft design, the bending moment found from the BMD becomes the value of moment in TE equals to square root of m squared plus t squared. But here you must understand these formulas. This te is equivalent torque equals to square root of maximum of moment squared plus torque squared. So um, this is our exercise of today. Thank you for watching. Try to practice this so that you can understand. What I realize is that in bending and twisting, they will request you to calculate the reaction. They will request you to calculate the shear force. They will request you to calculate the maximum bending moment. Sometimes they can even say you have to draw. Another point, you must understand, if they are not asking you about the shear force and bending moment, they will say calculate the diameter. But what you have to take it into consideration, then what you have to do, you must make sure that you calculate torque first. Thank you for watching. Thank you for watching.